Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, today in this particular video, we are going to see about how to calculate p-value. Now, many people have a lot of confusion with respect to p-value, significance value, and this is specifically related to hypothesis testing. And sometimes I also feel a lot of confused when I'm again revisiting the concept or when I'm teaching somewhere, at the same point that same thing will not strike and probably I have to revise again and again. So in this particular video, I will try to solve a problem and also try to show you with Python programming language how to calculate p-value and what is the importance of p-value and what is the difference between p-value and significance value. So first of all, let's go ahead and let's try to see this particular concept of p-value. And remember guys, I've just yesterday completed the entire 7-day live sessions on stats. The link will be given in the description regarding that playlist. You can go and check it out. Now here you will be able to see that suppose if this is my mouse, okay, I'll take an example to define what exactly p-value is, okay, or if you really want to understand what exactly this p-value is. Let's consider this is my mouse in my laptop and probably in this region, I'll be touching to basically move the cursor and all. So if I say, let's say that most of the time I'll be touching in the center region, so I can definitely draw a normal distribution curve kind of thing like this. And suppose if I say that at this point, okay, my p-value is 0.8, right? So this basically means that out of every 100 touches, okay, in this region, I will be touching 80 times. Okay, so this is basically the probability of touches that I am going to do. Okay, and similarly, if I probably touch in this region and suppose let's consider that the p-value is 0.01, this basically means that out of every 100 touches that I am actually touching this particular mouse pad, I will be touching in this region one time, right? So this is what basically p-value means. Okay, now let's solve a specific problem. Okay, now let's solve a specific problem, and this problem is basically called as z test. Suppose I have a specific problem which I want to really perform with the help of hypothesis testing. Okay, so let's consider a problem statement. Now in this problem statement, let's say that the average weight of city A is, let's say that it is 72 kgs. Okay, so this is my question, 72 kg with a standard deviation of value 4. Okay, so this is the standard deviation. I feel that I don't believe it, so I really want to do the test and try to find out. I really want to check out whether this is actually true or not. So, whether this mean, the average weight or this mean is true or not. So what I do is that I pick up a sample of, let's say that a sample of 36 people has been picked from the city, and when I calculated the mean, over here the mean was, let's say 74. Okay, so the mean was 74. I need to see that whether this true mean is different or not. This is the exact question. So here I will basically saying that at a 95% confidence interval, suppose I am considering 95% confidence interval, is there enough evidence to support null hypothesis? Now you may be considering what exactly is null hypothesis over here. I'll discuss about it. To support null hypothesis. So this is my question over here. Okay, so what is the problem statement? Understand that the average weight of people in a city, I should say of people in city A, is 72 kg with a standard deviation of 4. So first of all, let's see what all information is given. Your mean value is basically given. I have already uploaded videos on how to calculate or how to perform different types of hypothesis testing. What kind of hypothesis testing I will be performing, I'll talk about it. Suppose the mean is 72 kg. Over here, the standard deviation, the population standard deviation is 4. The n value, sample of 36 people has been picked, and then the x bar, that is the mean of those sample, is 74. So this all information basically I have, And here the information of confidence interval is also given, that is 95%. Okay, whenever we have confidence interval, with the help of this we can definitely be able to calculate our significance value. So here our significance value is 0.5. Now remember guys, we can solve this problem with the help of hypothesis testing in two ways. One is directly calculate your z score and probably do it. The reason why I will be using over here z test, because understand in z test the population standard deviation will be given, and apart from that your sample size will be greater than or equal to 30. Okay, so both the condition it is basically satisfying. So my first step will be that define my null hypothesis. Now my null hypothesis over here basically says that, which is specified by h0, your mean is equal to 72 kg. That is what I am actually trying to test by picking up a sample of 36 people, right? Then your alternate hypothesis will be h1, which will not, mean will not be equal to 72 kg, right? If this is rejected, obviously that basically means that it is not equal to 72. Okay, now understand the second step. I will definitely talk about my significance value, which is nothing but 0.05. Okay, so significance value is also given because I was able to find it out from the confidence interval. Okay, now coming to the next step, which is quite important. Over here you will be able to see that what test you need to apply, you have already got it, right? Here we will basically define our decision rule. What should be our decision rule? Now in this particular case, my decision rule, now first of all you need to find out whether it is a one tail or two tail test. Now people also get confused how to determine whether it is a one tail or two tail test, because understand we are basically checking whether the mean is 72 or not. It can be greater than 72, it can also be less than 72, right? So in this particular scenario both are there, right? Because we are checking whether mean is equal to 72 or mean is not equal to 72. If we go to the alternate hypothesis, even though the mean is less than 72, it basically means the mean is not equal to 72. If it is greater than 72, that also means the same thing, that it is not equal to 72. So in this particular case, we will definitely be applying two-tail test. If the condition was that check whether the mean is greater than 72, at that point of time we can use one-tail test. But here my scenario is to check from the sample whether the mean is not equal to 72. It can be greater, it can be lesser. So while specifying the decision rule, always understand over here in a two-tail test, based on our alpha value 0.05, we will be using two-tail test. Now in two-tail test, always understand this will be our 95% confidence interval. The remaining is 0.05. So here you will be getting 0.025. Here also you will be getting 0.025. Okay. So here are your two values with respect to this. Okay. Because this gets divided, these both are symmetrical, right? Left and right region are symmetrical. Now you need to understand what kind of test you are going to use. As I said that population standard deviation is given and n value is greater than 36. So the statistics that we are going to use is something called as Z test. Now how do you find out Z test? The Z test is very much simple. I'll open a browser. Here I will basically open a Z table first of all, because I need to know, right, what is this value, what is this specific value of 0.025 and what is this specific value of 0.025. What is the area under the curve, right? I need to understand what is this entire area under the curve. Okay, and based on this, what should be the Z score of this value? What should be the Z score of here and what should be the Z score over here? Okay, I need to find it out this. And in order to find it out, what I will do is that let's compute of this side first of all. If I compute of this side, over here only the negation will be there, right? Over here if I am getting a positive value, this will be the same negative value, okay, because both are symmetrical, right? So in order to calculate, now first step I need to basically take up this 0.025 and subtract with the entire area, because see the entire area is 1, okay, and then I subtract with this, that basically means this is nothing but 0.9750. So this entire area is 0.9750. I need to find out the area of the curve, right? Area of the body. Here I can also write area of the curve or area of the body. So here I am actually specifically trying to find out area of the body skipping this tail region. Okay, skipping this tail region. So obviously I will subtract with 1 minus 0.025, which is 0.9750. Now if I go back in the Z table, let's say that this is my Z table. Here you will be able to see that, okay, so this values, you can see this particular table, okay. So when I say area under the curve, I'm going to basically consider this table, right? So here is my table, okay. So here is my table. I'll just close this ad. Okay. Now 0.9750, just check where it is. So here you will be able to see 0.9750, okay. And based on this, what is the value? It is 1.9, 1.9, and from this particular column you will be seeing 0.06. So it is nothing but 1.96. So that basically means this z-score value, and this I have already explained you in my previous videos in statistics. This is plus 1.96 and this is minus 1.96, right? Minus 1.96. So that basically means my decision will be that after I perform a z test based on the data, if it is less than 1.96 or greater than 1.96, I have to reject the null hypothesis. Okay, because it does not fall in that confidence interval. If it falls in this region, that is less than 1.96, I have to reject it. If it falls greater than 1.96, I have to reject it, right? So I have written or. So this is my decision. This is specifically my decision, right? Now let's go ahead and apply our Z test. That is our test statistics. So next step, what I'm going to do, I'll go and perform this. And for this, obviously, you know what is the Z-score formula. X bar minus mu divided by standard deviation divided by root n. This is called as standard error. Okay. Sigma by root n. You can search for that also. Okay. So what is X bar? X bar is nothing but, what is X bar? If I see over here, X bar is nothing but 74, mu is 72. Okay. And n is 36 and sigma is 4. Right. So what I'm going to do, I'm going to write 74 minus 72, okay, divided by 4 divided by root of 36. This root of 36 will now become 2. This 74 minus 72 is 2 divided by 4 multiplied by 6. So 2 ones are 2 twos are 2 ones are 2 threes are. Now I am getting this 3 as Z score. Okay. So what is the decision I can make? Definitely 3 is greater than 1.96. Okay. So we have to reject the null hypothesis. I told you, right? We had two decision condition. One is if it is less than 1.96, minus 1.96, or if it is greater than 1.96. Now in this particular case, I've definitely got it is greater than 1.96. Now this way is the first way, by using significance value. Okay, by significance value. But when you do coding probably, you see something called as p-value. Now what exactly is p-value and how p-value is computed? Understand this step. This is super important. Now I have got the z-score. I have got the z-score value as 3, right? Now let me do one thing. Let me draw the curve again. Now I am not interested in 1.96. I am interested in 3. So when I say 3, so here will be minus 3, here will be plus 3, right? Now again I have to go to my Z table and probably based on this 3, what is the area of the curve that I should get? What is this area of the curve? Or what is the area under this particular 95% interval? That we need to find out. Now see this. Again I am repeating, guys. See, this plus 3 is the Z score that I got with respect to this distribution. So I have written plus 3 and minus 3 over here. Now I need to find out this curve area. And how do I find out this curve area? It's very simple. I will just go to the Z table and I will go to this Z score, and based on this Z score, it will give me the area under the curve. This entire area under the curve it will give me, right? So with that help, I will be able to find out. And now in order to find out this curve, what I'll do, I'll subtract with 1. That's it. That is what I'm actually trying to do. So let's see this, okay? So I'm going to remove this. I'm going to go to my Z table. Okay, I'm going to go to my Z table. Now with respect to this Z table, what I am actually going to do is that I will go and see where does 3 fall. So here you can see 3 is falling over here and I've got 3.0. So this is my value 0.9987, right? 0.9987. So what I am actually going to do over here, I know with respect to this, my area is nothing but 0.9887. This is the area under the curve, right? Area under the curve. Now, how much should the curve belong here and belong here? Like, I need to find out the area under this, right? So what I will do, I will subtract by 1 minus 0.9887. Now, if I subtract 1 minus 1 minus 0.9887. So I am basically getting 0.0113. So here I will be getting 0.0113. But understand, since this is a two-tail test, I have one tail over here, one tail over here. So this should be equally divided. So if I divide by 2, that basically means I will be getting 0.005. Okay. So let me see again. 0.00565. So 0.00565 will be here, 0.00565 will be there, and remaining area will be present over here. If I add 3, I will be getting it as 1. So this 0.9887 will be present in this region, right? So if I add it up, I will definitely be getting 1. But still, we did not understand what is p-value. So p-value is nothing but this area plus this area. So if I add 0.00565 plus 0.00565, I am actually going to get 0.00113, right? So 0.0113. Now, once I get it, I hope the calculation is right, but focus on the things that I'm actually doing. Now, how p-value is related with significance value, because this is how in coding also we'll do. Now, this is my p-value. We have to check whether this is greater than or equal to 0.05, which is my significance value. My significance value is 0.05, right? Now, you can definitely see that 0.0113, okay, is obviously less than or equal to 0.05. So what we do in this particular case, whenever the p-value is less than significance value, we reject the null hypothesis. Reject the null hypothesis. Now see, from both this scenario, we are getting the same answer, right? From this scenario also, this is my second scenario, which I am actually writing. From this scenario also, I am rejecting the null hypothesis. Here, I am just focusing on the z-score and trying to find out based on the decision boundary. Here, I am just trying to find out the p-value and then comparing whether to reject the null hypothesis or not, right? Now, this is the step, and this is how simple a p-value is basically computed and whether it can be compared with this significance value. Very, very simple. See the steps. In front of you, I've given an example. I'll solve the problem. This basically indicates that the probability is less than 5%. It's less than this. This is the probability, right? This is the probability, which is less than the significance value to support the null hypothesis. So we have to reject it. So we are rejecting the null hypothesis, right? So let me show you one code which I had written in one of my community sessions, in day before yesterday community session. Now in this particular case, let's see. I had the IQ. Basically what I have done is that let's consider that the average IQ of a population is 110. Okay. And then what I have done, just to test it, I have taken 20 patients, which I can also take more than 30 patients. Now don't fight me, Krish. You told Z test, the n value should be greater than or equal to 30. I've just shown you one example. You can definitely take 36, 37, any value. Okay. But understand, I've just taken a sample of values just to test whether it is working fine or not. Then what I've done, I've just used Z test, which is present in this stats.wage-stats. And here I've given the data, and here I'm given the population mean. So once I'm comparing with it, I'm getting the p-value as 0.0002. So this is my Z statistics value, and this is my p-value. Okay. Now here I can definitely write a condition saying as if the p-value, see how I'll execute it. I'll say this, if let me just save this in a variable called as p-value, comma p_value. Okay, so p-value. So I'll just write a condition saying that if p_value is less than or equal to 0.05, then I'm going to basically print reject the null hypothesis. So I'm just going to write reject the H0, right, which is null hypothesis. Else I'm going to print accept the H0. Very simple, right? So once we do this, it is doing, see, coding wise it is very easy. Now in this particular case, it is obviously getting rejected because your p-value is less than this one. That is, the probability is less than 0.05. Just imagine the probability is less than 0.05 to support H0. Okay, so if I probably print over a p-value, you will be able to see that it is 0.00027. So I hope you have understood this. There is a lot of confusion with respect to many people. It is also, I'm also having some time confusion with respect to that. So I thought of making this particular video so that you will be able to understand it. This will be super important in interviews. So I hope you like this video. Please make sure that you subscribe the channel. I'll see you all in the next video. Have a great day. Thank you and all. Bye bye.